All right, let's start. Today we will learn about the web security basics and then a little bit about the password, about like how we can secure the website with using the password-based authentication. And last week we learned about how the SSL and TLS works. So basically we learned about how we can secure the communication between the client and then web server. So we didn't authenticate the client. So what we have done is we try to authenticate the server and then do the secure communication, build the secure communication over the insecure internet. And then how it was done is because the internet by default, it is insecure at all. So when the internet was designed in the early 1970s and then late 1969 or something, so they didn't design the security back features about the internet. So surprisingly, when you communicated with over the internet without any kind of additional security by default, every packets are just plain text and then all the middlemen. And then on the internet, there are so many middlemen, routers routing your traffic, and that they all can see your traffic and also the returning traffic. So the problem is that all the middlemen can see the content of the network packet. And that's why we implement the transport layer security. And then the reason why we call it as a transport layer security is that, so not about the OSI reference model, we actually implement the TLS in layer 6 and 5, between this-ish. But in the TCP/IP, the internet network model, we actually placing the transport layer security in between the transport and application layer. And then by some of the examples, we have seen that the regular socket communication and then the TLS socket communication, it requires a minimal change in the application. And then the reason was when we designed the transport layer security, engineers want to make it transparent to the application. So and then it is designed to have a minimal change for the application. So that's not in the application layer. So it sits between the transport and the application layer. So that's why we call it as a transport layer security. And then you can regard the transport layer security as, at each side, the client and the server side, we will have a TLS module, and then we will run the regular applications at the client, just web browser, and then web service on the server side. And then it will use TLS module to negotiate the security factors and then encrypt, decrypt, and then and then for the integrity check that they generate all the keys and then verify all the things, confidentiality and integrity every time they exchange the packet. And then because when it gets through the TLS module, all the data is encrypted and then tagged with the HMAC, integrity check. So no matter what kind of things are done by the middleman, they cannot know the content because the content is encrypted with the secret key. And then they cannot alter the ciphertext as we have done in the CDC, ECD, CTR attack. They cannot do that because it is attached with the HMAC. And then that's how we secure the communication. And then after protecting the layers with TLS, the communication is something like, so even if the application generates a plain text, the TLS module will encrypt that, and then sending that over the network. So the middlemen will see the encrypted message. And then at the other part of the TLS module, it will decrypt that, and the server application will get the plain text. And then the same thing happens on the backward. So if server prepares this kind of the HTTP response, and then that will be encrypted in the TLS module for the server. And then that will getting out to the internet. So all the middlemen will see these kind of the random number kind of dish. And then that'll be securely decrypted at the client side. Then the client web browser can see the plain text content. And then to build this kind of the TLS and then secure communication channel, we need to go through all these kind of 10 steps. And then all these 10 steps we have gone through the details about like where we establish the authentication and then where we derive all the keys for the confidentiality and integrity check. Any questions for TLS and SSL before moving forward for the new content? All right, then let's move on to the topics for today. So we will learn about the web security for this week. And then the web is coming from the word World Wide Web. And then when the internet comes out, it has not been used for the commercial product for a while because the internet has been developed as a DARPA's ARPANET, which is for the having a fast and then scalable communication on the defense side, but that was released in public to be used in the public. And then like around the early 1990s, yeah. So there are a movement that the commercial services would like to share some documents over the internet. So that's actually like the sharing the web page, blog, or some of the services. So we are now using many services such as Facebook or like many other internet services. But in the very early stage, conceptually, they just want to share the documents over the internet. Yeah, that was even not possible in the early 90s. And then the World Wide Web, the term was coined around at that time to connect the entire world like a tightened web kind of thing. And then like everybody can access at anywhere for the document. And then to access the internet document over the internet, and then engineers define the protocol, network protocol for sharing the document. And then that is HTTP, the hypertext transfer protocol. Yeah. And then how HTTP works, it's something like whenever you try to get to access the slash index.html or slash login.php or that kind of website, what it does is like it sends a message in plain text, get this location with the protocol version, something like that. So I placed this kind of the request as an example, and then that's the real request that whenever we try to connect to top page of the website, and then the web browser indeed send this kind of message, and then as a response, a server will send the HTTP 200 OK, that kind of message. So the request is something like a get, post, or there are some of the commands, and then some of the path, and then protocol version, and then response will include a response code. 200 is OK, so legitimate access, and then you might have seen like the 404, so that's the error code for like the page not found, and then there could be error code of 500, and then that happens whenever the server has an error, or 502, that's another specific error. There are some of the error code, yeah, but the response is something like that, yeah. So for those who wants to know more about the HTTP protocol itself, please search about the HTTP protocol on the Google and then read about the Wikipedia page. And then they do have like a good description about that. But this is the security class, and then we will focus on the security of the HTTP. So I just introduced that over the internet right now, we are fully connected. And then if we know the IP address or domain name, then we can connect to the server. And then HTTP was designed to share the internet document web page over the internet. And then one problem is that if we publish some of the website over the internet, anyone can connect to the website. For example, is there any kind of credentials required for our course website? So definitely for the scoring website, it requires an ID and password to get into your data. But for the course website, it's public. There's no authentication at all. Yeah. So over the internet, we use the URL, the Uniform Resource Locator, to locate what kind of the web pages. Then that's actually the address or like the locator for some of the resource over the internet. So if we have like this kind of URL, you can connect from anywhere over the internet, and then you can get access to that. Then the question is that can we apply access control on the website? And then definitely we can do, because that's what we are using right now. And then early designer for the HTTP was aware about this kind of feature. So the HTTP protocol has an authentication method, but we don't use that much right now. There are several reasons, but we will learn about that first. So suppose we want to implement a web page to be authenticated by some of the username and password. And the protocol, HTTP, the protocol for sharing the web page, it definitely has the authentication method, so-called HTTP basic authentication. And then I created one of the challenge page. So when you get to the scoring server, course website, but the specific directory at here, underscore static hidden index.html, if you try to access that, you will see a dialog asking that the username and password. So you cannot get into the page, you cannot access the page. The server will refuse to deliver the content of the page if the username and then password mismatches. So this seems good, but I told you that we are not using this kind of method. Guess why? Yes? Why? Yeah. Yeah, description is right on the next slide. But yes. Yes, in the packet, the authentication string is delivered in plain text. So all the middlemen can get your password. And then that's the first challenge that we have for the web. And then I will explain how you can solve that in the following slides. So the HTTP basic authentication is insecure because it runs all the packets in plain text if we use HTTP. And then for the actual challenge, I shared one of the packet capture that actually captures the network traffic when I type the ID and correct ID and password for that website. And then you can download that from here, and then the link is also in the challenge box. You don't have to memorize that. And then if you download the file, then there are some HTTP GET and response traffic. And then to read it more conveniently, what you can do is you can apply the right click on any kind of the HTTP traffic, and then choose the follow and TCP stream. Then that will show you request and response colored like this. And then you will see that here, authorization, basic, and then some of the string data is here. Yeah. And then let's get into what that string is. So what is that string? So the string is not encrypted. It's actually encoded, and then in the scheme called base 64. And then what base 64 encoding is, so right now we are using a 1 byte that can represent from 0 to 255, and then using the part of that byte. So from the value 32 to 127, these are the printable characters. So all the alphabetical characters, special characters, numbers are all fall into from the range of 32 to 127. And then we use the rest of the 256, the values for just a binary value. So we use 8-bit to represent that character, but in base 64, we only use 64 characters. So what we use is from the capital A to capital Z, these are 26 characters. From small a to small z, these are another 26 characters. So we have 52 characters. And then from 0 to 9, these are 10 characters, 62, and then plus and slash. So including that, we could compose a character set of the 64 characters. And then important thing is that all the characters are visible and printable. Yeah. And then the reason why we are using that is, so 64 characters can be represented as a 6 bits. So it's something like whenever we have a data represented as a 8-bit representation, we can change those 8 bits into group of the 6 bits and then map each of the binary value to the character. Then no matter what kind of data we have, so right now we have a printable character ASD as a 3 characters, 8 bits, 3 characters, 24 bits. But if we split it 24 bits in a 6 bits group, then we will have 4 groups, and then each of the bits can be correspond to each of the characters in the table. So the encoding is like the encode this kind of string into Q, V, and the different string. And then you might be curious about like, why do we have that kind of encoding? So the thing is, so we are not sending all this kind of the printable characters. We might have some of the binary data. So I believe that you all have experienced that when we play with the encryption attacks, CVC attacks, or like the XOR, yeah, you need to play with all the binary data. Yeah, so we do have a lot of binary data. And then if we apply base 64 encoding to this kind of the hex characters, FF 255, E0, E8, those kind of values, then we can split into group of the 6 bits, and then we can represent as a printable character. So what base 64 does is like, no matter what kind of data you have, so in the 8-bit represented data, we have a not printable data. And then base 64 transforms that data into printable characters. And then we can inverse that. So the important thing is that there's no key. So this is just the encoding, not about the encryption. Yeah. Any questions about base 64 encoding? So the purpose is like the make all the data visible as a printable character. That's it. Yeah. So, and then you can easily identify some of the string is in base 64 encoding if all the data has a printable characters. So if some of the values are randomly generated, then they definitely have like a non-printable bytes. But if all the characters are printable, but you cannot understand what it is, not in English at all, but it has a slash, plus, or equal sign. So the equal sign is appended whenever there's some remaining data. So then not all the data is split into multiple of 6 bits. So in that case, we add an equal sign. So equal sign definitely basically represent the field, like the padding, or like the indicating the end of the data kind of thing. Yeah. So if you see slash, plus, equal sign, and then all printable English number character kind of thing, then you can regard that as a base 64 encoding. And then the reason why we learn about the base 64 encoding is that this string, the authentication string itself, so it is base 64 encoded. And because there's no key, and then it's not an encryption at all, so we can freely encode, decode the string. And then if you visit this website, there's an online base 64 encoder and decoder, and then you can also do that in Python or any other languages. And so this is the packet content that any kind of middleman can see for the HTTP basic authentication. And then we can grab this base 64 string. And then if we run the base 64 decode for it, then there's a string. The result is something like this. So it actually stores, it's actually like the represent username and the password connected as a colon, and then just apply base 64 encode and then send it over the network. Then what's the problem? Any middleman can do the same thing, can steal your username and password so that they can freely access your account. Yeah. So the implications. So we can easily apply HTTP basic authentication to apply access control on a web page. And then we can have a multiple username password combo, and then the client need to supply that kind of the HTTP basic authentication string encoded in base 64 every time they access the website. And on the server side, we can decode it and then match with the password. Then we can verify whether that's a legitimate user or not. But the problem is that the HTTP by default is not encrypted at all. So all the middlemen can see that thing. Then base 64 encoding is not an encryption, so we can actually see the content. Then you might be thinking that let's apply TLS and then use HTTPS. That might be the solution. Yeah. Because over the TLS, even if we deliver that kind of the authentication string in base 64, then no middleman can read that. Yeah. But there are another problems. Let's get into more details about the password. So the reason why we use password is to authenticate each user, and then we choose the password for some of the string that only that user knows. So if some other user knows the same password and then the other user can pretend as one of the user, yeah, that's problematic. Yeah. So the important thing is like the password is the authentication method based on what you know, and then only you should know, no one else should know that. Yeah. And then we can use that for the authentication. Yeah. So the problem of this approach is that, so we send this kind of the ID and password, and then server gets it, and then server knows the password, and then server has the plain text of the password and then compare that, yeah, on the server side. So you might think that like a server knows the password is okay because like a server should know the password to verify you are supplying the right password, but there's a problem. So I excerpted from one of the news article that like this is the news on today, and then the famous retailer Bed Bath Beyond, yeah, they affected by the data breach by some of the hacking, and then the reason why they hit by the hacking is that, so in the cybersecurity incidents like in 2019, some customer account has been breached. And then hackers had obtained username and password combinations from a breach. So then what that means is that like if the server knows your password and then stores in the server, then server program can also have the vulnerability. And then if the attacker gets in, then they can steal your password. And why is that a problem? So you use the password for the certain server, but the attacker gets onto the server, they have a full control of the server, then why do we care about the password? So even if they don't know about the password, they can do everything for this server. But the bigger problem is that all server can be hacked. And then if the server stores the password, if hacking events happens, that could be leaked. Then another question is that how many of the websites that you are sharing the same password across the several websites? For example, I'm using the same password for Facebook, Gmail, and several websites. And then if the hacker owned one of the website, then they can get the password, they can log into all the other websites of mine. So because we humans, we do not generate those many passwords, then we cannot memorize that practically. And then we have the tends to reuse some of the password. And that means if some of the server stores the password, then that could be security liability, and then security risk. Liability for the server and then risk for the users. Because if that server hacked, then the user's password will be leaked, and then that could be used for the other websites. And then the comment from the Zoom side was like, I have so many passwords because every website having a special requirement, and OSU making me change my password every 6 months. Yeah, the reason why the systems making you to change password frequently and then add special characters and then having a different rules for each website is like to make the users using the stronger password, not easily guessable, and different password per each website. But that also proven to be a bad practice, because even if the security researchers designed the super secure password with the lot of special characters in the middle, we all know that many people just attaching the exclamation mark at the end, or like put the 1, 2, 3, 4 as a number. Yeah, that happens because humans are lazy. Yeah. So the implication is that like we will learn more about that kind of thing in the user security at the end of this like the entire class in December, but never ask human users to do the complex things. Yeah. So that's the implication. So the problem is that if the server stores the password and then that could be leaked, so that is the problem. Then in authenticating the user, can we hide the password from the server? And then we can do that. And then we learned about the cryptographic hash, and then we can utilize that to verify the password while keeping the password itself as secret. And then how we do is, at the server side, instead of storing the password as a plain text on the server, what we will do is we will get the password from the user, and then we will not use that directly. What we will do is we will choose a secret key for the entire server, and then attach user password, and then run hash of it. So for example, suppose my password is something like this. Then whenever I type the password, then server will attach some of the secret and then run hash, and then it will be resulting in this kind of thing. Then, so the server will store this hash value, and then whenever I log in again, then I will supply the same value, and then server will supply the same secret. If the input is the same, the hash result is the same. So we can log in. But think about it. So this is the value stored on the server. So the hackers can breach this value, and then this secret, maybe hackers can breach the server's code and then read about the secret, but can the attackers obtain this value? So think about it. So attacker knows the hash, attacker knows the secret. Then the challenge is that can attacker inverse this hash to guess about this thing? And then we learned about the cryptographic hash. It must be very difficult to get the inverse of it. So which X generates this? So getting to that is super difficult. So finding an inverse of the SHA-256 is technically infeasible. So our password is protected by that. So these days, we don't use HTTP basic authentication for logging in. Instead, we use this kind of login form for the many other websites. And then let's take a look at the details about how we implement login in the web services. So suppose we have a web browser client and the server, and then suppose we are using HTTPS. So the connection is protected. And then client sends a plain text, the server the server will store ID and then hash of the password. And then the client type the username and type password. And then this thing will be securely delivered to the server side. And then server will never store this information. And then what server will do is run SHA-256 with the server secret and then put the password on it and then get this hash. And then try to check if this hash is matched to the stored hash in the database. Then the server can verify the client knows the password, and the chance of the client to randomly making the same hash is 1/2 to the 256. So very negligible chance. Yeah. So the server-side logic is that whenever user submits ID and password, and then run the SHA-256 with the secret and password, and then try to find the database about that kind of the username and the hash pair exists. Yeah. So what server actually does. So how many of you have learned about the SQL language for the accessing the database? Yeah. So I know that this class is in the junior level, and then some of the students have never taken database class. So SQL, yes, we call it as a SQL, yeah, is a structured query language. And then if you want to learn more about this kind of the syntax, then please refer to the example website that I place in. And then what this language does is this is the language to fetching some of the data from the database. And then it resembles some of the natural language. And then let's follow about the current query. So to retrieve the password and then verify that, what we need to do is select username and password pair from users table. So there is a table in the database where username is my user ID, so supply the user ID from the user, and the password is running SHA-256 secret and then added with the my password. So what this query will do is it will try to find this pair, username and then hashed password. And then if this where clause matches with the sum of data in the row, then it will return as a username and password. So the user sends the plain text password and then plain text username, but in the database, permanently store the hash of the thing, and then we will compare the hash to match the password. And then even if the attacker knows the secret, they have to inverse SHA-256 to get these kind of passwords. So that's why we have the security over that. One question from the Zoom side, why do we not hash the username? So the thing is the username is not secret, but if that needs to be secret, we can also hash that. But if we hash the username, then maybe we can permanently store the hash of the username and then get the username from the user and display whenever the user has login. Yeah, so that's also possible. So to create some of the to hide the list of the usernames, we can also apply the hash of the username for that. Any other questions about this kind of the mechanism for checking password with hash? Yes. 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 So you are guessing that the bet beyond definitely not using the naive mechanism, right? And then they definitely use hash or that kind of thing. And then how that could be the password got breached. Yeah. And then I have a slides for that. Yeah. So this slide is related to that one. So One of the problem of using this approach is that SHA-256 is susceptible to brute force attacks. Yeah. So what brute force attack is like trying all the strings. Yeah. So suppose an attacker breached into the server, for example, Bed Bath Beyond, and then they can have all the database. They can steal all password hashes. And then if they can take a look at the server program code, they can also steal the secret. Yeah. Then what they can do is they have all the hashes. And then what they can do is for all kind of strings, they can calculate secret concatenated with the string, get the hash, and then compare if that hash matches to the something in the database. If that matches, then we can uncover the plain text value for it. Yes, it definitely needs to take a long time because the entire search space for the SHA-256 is 2 to the 256. So it requires the several more than a trillion years or something. Yeah, but there are some practical attacks against that. So theoretically, it should take around the 2 to the 256 time, but practically, this is not true. The reason is that the human users choose password not entirely randomly. Yeah. So the security factor of the SHA-256 is 2 to the 256, and then that applies only if we choose the data randomly. That's how cryptographers have proven. But the problem is that the human users choosing password from something easy to memorize and easy to type, something like these, and then combining some familiar phrases or some of the word, attaching some of the number, last 4 digits of the phone number or birthday, yeah. And then special characters or mother's maiden name, those kind of information that somebody else can easily identifiable, yeah. That could be used in the password. And then this is the top 30 most used password in the world. Take a look at those. And then you will see that how lazy people are. Yeah. And then some of you are thinking that, oh, I'm good. I'm not using that password. I'm concatenating 5 words and then in the number and it'll be secure. But please don't have that kind of belief because for launching the brute force attack, we do not choose a string randomly. Attackers may use some of the dictionary corpus of the password from the known password phrases and then popular words and then that kind of thing. And then they can mix and match those words to generate the password. Then the search space, definitely not a 2 to the 256. It's combination of the viable words and then combination of it so that we can reduce the search space drastically. So, and then there are some of the GitHub or some of the public data. And then if you go to there, and then there are a lot of text files. And then this is one of the content of the file. And then what they serve is they serve a corpus of the commonly used password. And then what attackers can do is just trying those passwords with the secret hash. And then if any of the thing matches with the database, then they can use that password for another website. Then that kind of the dictionary attack can be possible for the breached hashed password. Any questions about it? And then many websites ask users to include different set of the character sets, not just for the lowercase, use uppercase and the numbers and the special characters. And the reason why they are asking users to do so is as follows. So think about assuming that users are generating random password completely, and then suppose they are using 8-character password. then the number of cases that attackers need to try, if it uses just the uppercase, then 26 to the 8. So this amount, 208 billion. And then if we add lowercase and then mix the lowercase and uppercase, then the entire case will be much more than that. And then if we include these kind of numbers and then special characters, then the number is getting bigger and bigger. So suppose we are using super strong password using all special characters randomly generated with the 8-character password. Yeah. And then some other websites requires like the longer than 20 characters, 15 characters, something like that. The reason is like increasing this number by having a exponential factor for the and is applied on the length of the password, and then that's why to make the attackers need to try harder for that. So in this case, if you just add one more character, then the difficulty of the attackers will be increasing 95 times. 2 more characters, then around the 10,000 times, yeah, increased. And then, assuming that we need to launch full brute force attack, then if we use all these characters and then special characters for the 8-character password, this is indeed like this 6,634 trillion cases. Yeah, so it's quite enormous. But I have one question. Do you feel that this number of the trials required for the attackers are secure enough for the password? And then many already knows that if I ask something like something yes, then the answer will be no, right? So you should never think that this password is secure, because have you heard about like that there are like there are people who are using a lot of powers for Bitcoin mining? And then what Bitcoin mining is doing is that there are a pool of the transactions. And then what they are doing is that there's a transaction data, and then there is a part that they can put the random number. And then by changing this random number, they need to get a hash 256, SHA-256. And then the difficulty of the Bitcoin mining is defined by how many of the leading zeros are there. So for example, SHA-256 will generate randomly looking 256 bits of the data. Then if the Bitcoin network sets the difficulty as 80, then what that means is that one need to find hash of the transaction data and then random number to be having 80 zeros at the front and then random data. So that we need to have the SHA-256 result of having the 80 zero bits. And then the chance of getting that is actually 2 to the 80, 1 over 2 to the 80. Yeah. So maybe in that case, like you'd better think that better to purchase a Powerball. Right now it's 1.2 billion expected. So that has like the better odds than like the matching that kind of the Bitcoin hash. But that chance is where you use the one single core of the CPU, then you will take forever. But right now, they are building this kind of the rack of the GPUs to parallelize all the hash calculations. And then this is the data that I got from the Bitcoin mining pool. And then because like all the other parties are competing each other to get that specific hash, so like to get more Bitcoin, so Bitcoin miners need to put more GPUs to have the hash rate faster enough like this. And then one of the biggest pool called the Foundry USA, yeah, they can process 71 exa hashes per second. Then the implication of this is that, so if we use all the characters, the special characters, and then 8 length. Then that will result in this much amount of hashes need to be calculated. And then this is actually 6 peta cases. Then they can process 71 eta, which is 71,000 peta. So your password can be cracked in less than 1 millisecond. Yeah. So even if this number is bigger, do not believe that your password is secure. You always need to learn about the enemy's power. And then these kind of the Bitcoin miners. Right now, the Bitcoin price is quite high, so like they just crack the hash for it. But when the value of the password gets higher, then all the retired Bitcoin miners can be transformed into this kind of the hash cracking thing. Yeah. And then to share another thing, as an undergrad student in 2009, I wrote the undergraduate thesis. And then the topic of that thesis was like the building a CPU that calculates hash on purpose to break this kind of the password. Yeah. So I made a password cracker in FPGA. Yeah, as my undergraduate thesis. And then like at that time I was just really into the security, and then I just want to focus on that kind of the thing. But then many people says that I should build a Bitcoin miner at that time, not about the password cracker. Yeah. So any questions about this kind of implication? Yes?
You said that if they reach the data, they can find the secret number for SHA-256. What if they have like a lot of secret numbers?
So if there's a rule to choose specific users a secret number. So for example, suppose we use some of the secret attached to the username as a specific user or something, or user supply, that kind of secret, and then that need to be stored into somewhere, right? Yeah. And then there's a logic that the user supplies some data and then we derive that kind of secret. And then if the attacker knows the entire path, then if the attacker can regenerate the secret, then they just need to guess the password, right? And then in the early days, so right now the practice is like that whenever you hash the password, you need to have the secret in front of it to make it as an HMAC kind of a thing. So hash with the key. But I believe that 10 years ago, many of websites just hash it without secret at all. So in that case, there's a so-called rainbow table. And then what hackers have done is like they try to compute all the hash. And then because there's no secret, and then that could be universally used by all the websites that does not have the secret. And then you can search for the password rainbow table. And then if you put like some of the hash on it, then you can get the immediate result for the password, something like apple, brown, butterfly, that kind of a popular word, because like the hackers have pre-built that kind of the dictionaries for it. But if we use a secret, then we cannot reuse the public database. We have to calculate by our own as an attacker. And then if you change the secret, then it can increase the bar to the attacker. Yeah. But the important thing is like we should increase the bar to counter these kind of numbers. Yeah. So I believe like for this kind of cases, so we have like a 0.1 millisecond, 100 microsecond for this one. But if we increase the password length 16 characters or something, then it will increase less than 1 millisecond and several days. Or if you increase the password length as 20 characters or something, then even for the entire Bitcoin miners try to crack that, then like they need to spend like several years for that. Yeah. So I believe that better ways to do that is like let users use a longer password. Yes.
Well, so you're saying that you could like traverse like a database of known passwords. Mm-hmm. Why wouldn't you just want to encrypt the user's account, like account name, because that's going to be unique. So that would just defeat. I feel like that would just make SHA even more secure if you just did it to the account name and the password.
So the one question is like if we encrypt user's name, where will we store the key for the encryption? That's the problem. But if we can hash the username, but the attacker can also crack that using the brute force manner. And then I believe username is much shorter than the password.
Like the brute force method, because like your username is unique to you, and there's only typically one account name. Like you wouldn't be able to create a database full of known passwords or like known username.
No. So we are not creating the database for the known usernames and known passwords.
Well, I'm saying that you said that they use like a known passwords.
Yes.
Like database or something, right?
Right.
But if it was an account is unique. Like the account name is unique itself. Whereas like a password, you could have the same password for like 100 different accounts.
So what I'm saying is like suppose you have a hashed username, attackers can crack that too. And then username is much shorter than password, much easier to hack, much easier to crack with the brute force attack. And then like what I'm saying is like even if you hash the username to hide it, then it just increase the factor of attackers a little bit, not drastically like we increase the length of the password.
Okay.
Yeah.
I essentially wasn't saying that it was like uncrackable, but it would like expand the time to where it's unreadable.
Yes. And then which do you prefer? Adding as a factor or multiplied as a factor, right? That's why. And then that could be used for hiding the username too. Yeah. Any other questions? And then I prepared the challenges for like the HTTP basic authentication, and also another set of challenges that you can bypass that the password-based authentication on the web server. And then like I will not get into the more details about that, but I will just explain that like how you can use a technique called the SQL injection to log into the server without having a password at all. And then I set up a server. What that runs is like a select username and password from users, where username is this one, and then password is this one. And then to simplify the attack, I didn't hash the password, but that does not change that does not block the attack could be happen, because we are not using password to bypassing the login at all. And then the important thing is that like for hashing the password, we will store the username and then hashed password pair in the database. And then whenever users supply username and password, we search for it and then retrieve the password vector for it. Then the attacker's goal is not about the matching the password. If they can, in whatever manner, this kind of the SQL query returns some of the valid data, then they can log in. So think about the part that we type the password is controllable by us. Then what if we supply these characters, quote or quote A, quote equal quote A. And then this structured query will be transformed into select username password from users, where username is this one, and the password is just a null, and then or A equal A. So take a look at the where clause. Username is this one, and password is this one. And then the priority for the operand is higher on the end side. So you can regard end as a multiplying one, and then or as an adding one. So the end is higher. So we apply end for this, and then we can find no entry because we didn't supply password for it. But there's an or clause, then A is always equal to A. Then this statement is always true, then it will return username password for it. So that even hackers don't know about the password, then they can log in into the system. And then SQL queries, they do have like the many other functionalities. Yeah. So you can inject something like this to bypass where clause, or if you need to log into the specific user, for example, administrator, then what you can do is you can also use another command of the SQL command. So you can think it as each database query as a set, and then there's a union operation, and then union means like concatenating two results. And then if we supply this kind of string, then our SQL query will be something like this. So this select finishes it here. And then because we didn't type any kind of password, so it retrieves a 0 result. But right next to there, it runs a union select admin and A. And then we can arbitrarily write this, and then where A equal A, then this will be always true. Yeah. Then we type the username as an admin, password as an A, but it returns a valid result. Then the server will let you log into the system. Yeah. So this kind of the vulnerability was discovered in like their 2005 to 2010-ish, and then like it was like a very serious problem in that era. But in these days, we mostly do not use a database query directly, and then more likely some of the web services, for example, Flask or Django or Ruby on Rails or Spring, this kind of the web framework, they do have some of the secure way to running this kind of the login queries. So they prohibits like the injecting of this kind of the quote characters, yeah, to be used as like this kind of the query string. Yeah. And then as a tutorial, we will practice about the SQL injection, and also for the Wireshark demo for the like getting the password for the HTTP basic authentication. And before getting to the tutorial, any questions for the lecture side? All right, and let me share the entire screen. Then let's take a look at the web challenges. So like for the HTTP basic authentication, we have two challenges. One is for identifying the username and password from the website. And then the second one is like the actually visiting that website using the visiting this website using the ID and password. So for example, if I visit this website, it prints nothing, but they ask the username and password. And then right now, I don't know, but so it says authorization required, so I cannot access that. But the challenge provides the packet capture. And then if you download it and opening it, then you will see that the HTTP request and response. And then if you click right on the any kind of the HTTP packet and then follow the TCP stream, then you will see that this kind of the result. And then from the request side, you can see that there's a basic authentication material. And then, excuse me, if you visit base64 decode website, decode it, then you can see the password here. Yeah. And then the username is this one, and then password is in this one. Then you can just copy it. And then when you visit this website, then you can type username and password. Then it will let you log in. And then you can get the second flag here. Yeah. So please follow the instructions to get the username and password from the network traffic. And then please practice that you can actually get onto that site by using the stolen username and password. So these are the easy thing like that. And then next one is about the SQL injection. So we have 5 SQL injection challenges. And then the first one says, can you log in to the website users other than CS370? So what it gives is that it has a login form. So if you click on it, so that this is the different login form than the scoring server. So that I have logged in for the scoring server, but this is a special website that I designed for the challenge. So you can type the challenge username and password. And then in the challenge, there is a sample username and password. Username is CS370, and then password is this one. So if you use the default username and password, let me check on it. I need to fix something. I don't know why but the server is so slow. Now it works. Yeah. So CS370 and the CS370 password. So if you log in, then the username is CS370, but there's no flag if the username is CS370. So you need to log in with a different username to get the flag. And then let's go back to the SQL injection challenge. And then the challenge asks that can you log into the website, the user, other than CS370? And then we know the query string. And then we can inject either username or password. So suppose we are injecting something at here, and then we will cut the where string and then put or, and then make it as always true. And to do that, we can type whatever username. We don't care about the password. And then we will just check how it works. And then this generated the error because our query string is this one. And then I just put the single quote, and then it has a tailing quote in here. Yeah, that's why it does not work. And then to match that quote need to be consumed. Then we can put the string like this. Yeah. In that case, so it will, the first quote will close the password part, and then or string A is equal to, there's no ending quote, but that will be automatically added by the query string itself. So if we do so, then our query string will be always true for the where clause. Then it will let, the server will let us log in with the different username. So what it just did is like that we made a where clause always true. Then what server will do is like it will fetch all the username password and then choose the first one. And then I put my username blue90657 as like the first row entry of the database. And that's why it comes with that. That's the SQL injection 1. And then, so SQL injection 2 is that. So can you log into the website as the username admin? Then let's write another query string. So suppose we put some of the, just a single quote to generate the error to see the query string. Then I will compose a new query at here. So this is the character that I just typed. And then I will just have a new line to distinguish like the where clause. And then we can control this part, not about this quote and then that quote. And then we need to make the query string to retrieve the username admin. Then how can you do that is we can put quote to close this end clause, and then we can add or, and then we can specify username here. And then there's another username called red9057, and then I will use this for login to the system. But the last quote is supplied by the password itself. And then first quote is the password query string supplied by password query string itself. So what we actually need to type is this. Then the entire query string will be having always false for the first end clause. And then or username is this one. And then it will fetch the one database vector that matches the username to this one. Today, I will type this. Then it let me log in with the red9057. But your task is that you need to log in as an administrative user, to do so. Then you will have a different flag for that. Any questions about like this kind of the launching the SQL injection to make the database query condition to be always true or specifically true, to retrieve the specific user or something? So the implication is that, so we learned about the password and then we defend about the password, but there is a way that attackers don't even know about the password and that they can still get onto the server. So the password is one of the things that we can build for the security. And then there are many other ways that the hackers can hack into our system. So we need to defend a lot. But I want to demonstrate like for the password security. It's not directly related to the password cracking or something, but the user password could be avoided, when we use with the SQL database. And then third injection is that, can you steal the password of the user? And then I will demonstrate how you can steal the password of the not this user, different user, red 9057. And then let's do that. So this was the query string. And then we will put some of the query in the middle. And then what we will do is, so by typing this single quote, we can close the first query. And then SQL can be unioned with the other nested query. So what we will do is, so we know that this will result no result at all. And then we will put union, select, and then previously it queried the username, but we need to get the password. And select password from users, where username, red 9057. Then the entire query will be something like this. So that this part resulting 0 result. And then this part will return the password of the red 9057, but the server code expects it is a username. Then it will display the password in the username field. So instead of the printing red 9057, if we run that query, then the server will present password for it. Then let's do that. So we need to preserve these two quotes, and then these are from the query stream. Then what we need to inject is this one. And then if we inject that kind of string to the password, then now you see the password of the red 9057 was retrieved. And then you might be curious about that this is the right password or not, then you can check it. This is the correct password. Yeah. Any questions? Yeah. You can do that. Yeah. So that's why I'm creating challenges for the, you need to log in to the specific user. You need to steal user's password. Yeah, something like that. And then there was a question from Zoom. Oh, so it's about the comment. Yeah, right. And then let's take a look at the last challenge. So the last challenge definitely has some more points because it requires a little bit of trick. And then what they say, so all the upper parts are the same. So you need to attack the login page. And then what it says is that there is another table called the secret. And then it has the text data field named the secret. Can you steal the secret stored in that table? So now we know that we can run the union query. And then we previously running the union query on the users table. But there's no restriction that we can run the query only to the users table. We can run the query on the secrets table. So what that means is that from the login form, you can actually steal any kind of the database data. And then this challenge is for practicing that. But the problem is that this website limits the username up to 40 characters. So it does not show you more than 40 characters for the username. But the thing is, the flag is 127 bytes. So what you need to do is you can launch union query, secret from secret, but you need to apply substring function to get the first 40 characters, next 40 characters, next 40 characters, and the remaining characters. And then if you combine everything, then that will be the 127 bytes flag. And then I will demonstrate how you can get the first 40 characters and the next 40 characters. Question? Pardon? It's down again. I believe now, so the maximum number of files to be opened has been changed. So it will work well. Yeah, so this number matters. Yeah. So after this class finishes, I will make sure that the server need to be stable for your challenge solving. Yeah. So let's make this kind of query. So that we will union and then select from secret. And then the query string that we need to write is in the middle of this one. And then what we want to do is like a close the first select. Then we want to do union select secret from secret. And then where. So that the reason why I put where this kind of thing is that like it will be closed with the tailing quote in the query string. And the entire query will be something like this. So the query looks legit. Then what we can do is just making as a string. And then try to use that string to fetch the secret. Then it seems like it fetched some of the data, but the problem is that it only shows the first 40 characters of it. Then we can apply for the result. We can do substring on from the first character about size 40. Then we can get the 40 characters at each time. So we got the first 40 characters. And then to get the next 40 characters from 41st, getting 40 characters. If we do so, then we can get the next 40 characters. So you can do that again and again until the end of the flag. And if you concatenate all the retrieved data, yeah, then you can get the flag for this challenge. So the implication of this attack, the last step, was that you can fetch any kind of data from the database. And then even if there's a restriction that the username is limited to 32 characters, 10 characters or something, and then you can run substring many times, then you can eventually retrieve and then steal all the data from the database. Yeah. Any questions? Yes?
We're getting it because the theory is displayed on the website.
Right.
What if it's not displayed on the website?
So even if that is not displayed in the website, so we can make a conjecture that. So what is the simplest way you can write a query? And then there is a quote for the password. And then that's why I'm trying this first. So that we don't know about, suppose we don't know about the information about the server, then just try this. And then if it does not work, then it will show a little bit of error message, or like you could get an error, but you can try to guess like if suppose. So let's make another conjecture. Suppose query is something. So right now the query looks like this one. Then this works, right? But suppose the query was query is something like this. Then to close it correctly, we need to put something like this. And then here, I didn't teach you about this kind of thing. So if you put like the dash dash in a SQL string, and then that will regard the rest of the things as a comment. Yeah. So it will run the query up to this point, and then ignore the rest of the thing. So that the challenging part was that we don't know about where. So if there's a parenthesis like this, then our magic string, this does not work because so it is applied or inside of here. So to correctly ignore the first query result, then attach the union, then we need to close this clause. Yeah. So it depends on the server query string, but even if we don't know, we can make a conjecture and then try to push this kind of thing, or this kind of thing, or there could be two function nested. Yeah, and then you can try it many times, and then if there's no error and saying just login failed, then your query string is correct. Yeah, so that you can learn about some of the side channel of the query string from there. Yes.
So I'm saying in this website, it's like the quotation percent S the quotation.
Mm-hmm.
But what if instead of querying select secret, I want to get all the data of the users, then I put in select star from users, but then in this website, it's not working.
So because like it will fetch one by one, and then there is a way you can concatenate all the results as a single string, and then you can use that. But the problem is that this website only displays 40 characters, and then if you need to concatenate all the string, then like you need to substring in a 40 characters, yeah, to still steal all the data. Yeah. So I forgot the exact command, but yeah, there is a function called group concat. What it does is like if we apply selects username and then group concat, then it will concatenate all the rows and then make it a single string and then result one result. Yeah. Any other questions? All right, this is the part for today. And then I will stay here until 4 p.m. So please work on the challenge and then ask any questions to me.